Welcome to 5-3 absolute value equations. We've dealt with absolute value equations before, but we've mostly just graphed them. So I wanted to take a minute and review what the absolute value graph actually looks like. So this up here in the corner, we have our parent equation, y equals the absolute value of x. And what you need to know about the absolute value, these two lines here, is that they're referring to the distance from 0. So if we look at this as 0 on our horizontal, on our x-axis, if I'm 3 away from 0 over here, or I'm 3 away from 0 over here, the direction doesn't actually matter. So whatever comes out of those absolute value lines is going to come out as a positive, thinking about that as a distance from 0. So the parent graph for this, if I have the absolute value of 0, that's going to be 0. If I have the absolute value of 1, it's going to be 1. Absolute value of 2 is going to be 2. Absolute value of 3 is 3. Same thing on the negative side. Absolute value of negative 1 is positive 1. Negative 2 is positive 2. And negative 3 is positive 3, so on and so forth. So that is our parent graph. This particular equation up here has been transformed. So if you recall, y equals a times x minus absolute value of x minus h, and then plus k. Hk is that point right there, and a is your stretch factor, which tells you how much you're going to go up or down rather than the current. What we have is the current out one and up one. So that number right there tells you instead we're going to go out 1 and up 2. So in this particular equation, our hk, you have to be careful with the negatives here because that's an x minus h. So we have an h of negative 1 and a k of negative 3. So we're going to graph, let me erase that arrow real quick. We're going to graph negative 1, negative 3. That in blue. So negative 1, negative 3. And then instead of going out 1 and up 1 in both directions, because the a value is 2, I'm going to go out 1 and up 2 in both directions. So this is my transformed, and that got a little messy after a while. That's my transformed absolute value, the one in blue. So creating a table, I'm only going to do a couple of values, but I wanted to remind you of how the absolute value actually works. So let's say I pick the values negative 2, 0, and 2. So the first one, I just plug in 2 from my equation, plug in negative 2 from right there, that's just the value that I decided on, plus 1 minus 3. And then I just evaluate. So I got y equals 2 times the absolute value. Negative 2 plus 1 is negative 1. And then minus 3. So I've got y equals 2 times the absolute value of negative 1, which is just 1. So I'm going to get rid of the absolute value lines. 2 times 1 is 2 minus 3. 2 minus 3 is negative 1. So negative 1. And I can see that where I go, so negative 2, negative 1 is my negative 2, negative 1, so that's that point right there. For 0, same process. Y equals 2 times the absolute value of 0 plus 1 minus 3. 2 times the absolute value of 1 minus 3, so that's going to be 2 times just 1, because the absolute value of anything is going to be the positive. 2 minus 3 is also negative 1. So that is that point right there. And then my positive value, I'm going to erase some of this to do that last one. My positive 2. So 2 times the absolute value of 3. Whoops, wrong one. Minus 3. That's the same as 2. And of course I'm showing you a lot more steps than are critically necessary, but I do want to note the order that we're going here. So that's going to be a value of 3, and that one was also negative 1. So this one, if I had actually graphed that correctly, would have been going through that point right there. So moving on. The investigation that we did in class, I'm just going to walk through what I would do if I were you, as is often the case in these videos, is when I get to a new screen, pause, attempt the problems yourself, and then check and see if you're good to go. So the first one, absolute value of 5 equals 5, that is true. Second one, over the absolute value of 5 is negative 5, that is not true. That one is false, because you can't come out of the absolute value lines to be a negative. You can go into the absolute value lines, but you're going to come out a positive every time. So the next one, absolute value of negative 5 is 5. That is also true. And the final true-false one, absolute value of negative 5 equals negative 5. That one is also false. And those two on the side are false because of those negatives in front. So going the opposite direction, if I know the absolute value of this something here equals 5, then there are two different things that can be in the position of x. So I can put a negative 5 in for x and still get a positive 5 out, and I can put a positive 5 in for x and still get a positive 5 out. So that answer is going to be plus or minus 5. I can also write that as positive 5 and negative 5. Let me erase that though. And the next one, absolute value of x equals negative 5. This one does not have a solution because there is absolutely nothing that I can put in for x and take the absolute value of it that is going to come out a negative. So that one, no solution. So next up, circle all the equations, all the equations that have no solution, and box all the equations that have 2 solutions. So anything that does not have a solution is going to be a negative once we get the absolute value part alone. So as I'm going across here, that is absolute value equals a positive. This one is absolute value equals a negative. So that one I'm going to circle because that does not have a solution. As I go across the row, absolute value of x equals 0. That actually just has one solution because it's just 0. Here we have the absolute value of x minus 4 equals 1. To get that x alone, we'd have to add the 4 to both sides, which would make this a positive, so that one has solutions. Same thing with this one, I'd have to add the 4 to both sides, so I have absolute value of x equals 3. Over here, I have absolute value of x plus 4 equals 1. What I would have to do in that situation is subtract 4, leaving me with a negative 3 in the absolute value of x. That one is not going to have a solution. So I'm going to circle that one. Same thing with this one, minus 4. I'm going to have a minus 5 over here, also no solution. Next one over, absolute value lines and what's in it are alone, equaling a positive. That one's okay. This one equals a negative, so that's my fourth one that does not have a solution. My 2 solutions are not that one, sorry. The others, and then the x equals 0, absolute value of x equals 0 is the solution. So I know it doesn't have a solution if once the absolute value lines are alone, it equals a negative. So it's really sloppy. I know it's going to have one solution if, and I'm just going to say once the absolute value lines are alone, so I'm just dashing all those. In that case, wow, that was messy. Comma, it equals 0. And it will have 2 solutions if it equals a positive once the absolute value lines are alone. So, once again, I would suggest you pause and check your answer, or try these on your own and then check your answers. In all of these cases, we have to isolate the absolute value part before we can do anything else. So you can't do anything with what's inside of it. You have to deal with the parts outside. So on the first one, I'm going to add 4 to both sides. So I've got the absolute value of x equals 5. I know that x can equal 5 or negative 5, so that's my answer on that one. On part B, I'm going to add 4 to both sides. So I've got the absolute value of x equals 3, so x is positive or negative 3. On part C, I'm going to subtract 4 from both sides. So I've got the absolute value of x equals negative 3. That one has no solution because of that negative right there. Whenever you have a problem that has no solution, if it happens on a test, make sure you show the steps up until the place where it says there's no where you can point out why there's no solution. Part D, anytime we have a number right up next to grouping symbols without a sign in between them, that means we're multiplying, so this is 2 times the absolute value of x. So I need to divide both sides by 2 to get rid of that. So I've got absolute value of x equals 3. So once again, I have x equals plus or minus 3. And the last one, I got a few more steps to take. Got to get rid of the 7 first. Keep in mind when you're thinking about the order of operations, so parentheses, exponents, multiplication, division, addition, and subtraction. When you're solving, you're basically going the opposite direction and undoing all of those as you go through those. So the inverse operation to adding is subtracting. So I'm going to have 3 times the absolute value of x equals, let's see, 25 minus 7 is 18. And then I'm at the backwards of the multiplication and division. So I'm going to undo the multiplication by dividing by 3. Absolute value of x equals 6. And then I can split it, so I've got the absolute value of x, so x equals positive or negative 6. So my first step in this is really, and we're going to write this down in a minute, so I'm not going to write it down right now, but is really to get the absolute value group, whether it's just x, because it's not going to keep being just x, but I'm going to get the absolute value group by itself. And then I'm also going to make sure that it equals a positive, not a negative. So we'll get to that in a moment. If I look at this is what I did here, absolute value of x equals 5, so I can split it into a plus 5 and a negative 5. Once you have that alone, you need to split it in the positive negative. It's the same idea here, even though I have x minus 4 equals 1. Whatever's inside this whole thing, if this was just x, absolute value of x equals 1, then x would be positive or negative 1. And that's still true even though I have the x minus 4. So this is going to be a positive 1 and a negative 1. And then I just solve them both separately. So I'm going to add 4 to both sides. So I've got x equals 5. Again, add 4 to both sides. And I want you to take note of the fact that the x minus 4 itself, the part that was inside the absolute value, did not change at all. Negative 1 plus 4 is 3, so my two answers are 5 and 3. So looking at 4 and 5, I'm going to combine those. Pardon me. I'm going to combine all that, do my inverse operations to get that alone, and then split. So I'm going to add 4 to both sides. So I've got 3 times the absolute value of x plus 6 equals 9. And divide by 3 on both sides. So I've got the absolute value of x plus 6 equals 3. And at that point, I'm going to split it into my positive. So x plus 6 equals a positive 3, and x plus 6 equals a negative 3. So I subtract 6 from both. So I've got x equals negative 3 for one of my answers. and x equals -9 for my other answer. So if I were you, I would take this example and I would put it in your notebook. Then underneath it or next to it, I would write the two steps that we're going to write down next. Screen's back. That's what I got from the exact same equation, -3 and -9, when I solved it algebraically. So summarizing how to do this, the first step is to isolate the absolute value group. And then check that it equals a positive. And then the next step is to split it into the positive and negative of the other side of the equation. Then just solve each for x. So we can also use a graph to check our work. The way that works is we're going to take this part of the equation, the 3 times x plus 6 minus 4, and we're going to graph that by itself. So x plus 6 minus 4. And then we can take the other side of the equation and make it its own equation, y equals 5. So if I graph this right here, I'm going to remind you this has an HK of -6, -4, and it has a stretch factor of 3, so we're going to go out 1, up 3. And the graph point -6, -4, go out 1 and up 3 in both directions, and I'm just going to keep doing that because I know I have to go fairly high on this one. And it's important anytime you're checking or solving by graphing that you are graphing as precisely as you can. You can see clearly the points of intersection. And then my other equation, y equals 5, is just going to be a flat horizontal line at 5. So that's going to go straight across there. And what I'm looking at are these 2 points where they intersect. So the points of intersection are -9, 5 and -3, 5. But if I look back at my original equation, 3 times the absolute value of x plus 6 minus 4 equals 5, there is no y variable to solve for here. So I don't actually want the full points. I only want the x values because that's all I wanted to know to begin with. So x equals -9 and x equals -3. And so that's checking by graphing. And that's it. If you were not in class and you didn't hear me talk about it, I would double check and make sure that if you're going, especially if you're going for highly proficient level, make sure on the practice worksheet you do the checking for the extraneous solutions. And that's it for this one. So have a good one.